Hi everyone, welcome back. If you want to support me, please press like and subscribe. Here we go. Differentiating exponentials. I don't want to go into the deep and meaningful again about why and how they work. I've been dreaming about making a video on that. This is just what are the mechanics, what are the processes, and what are the situations that can trick me. First of all, if I'm going to write the derivatives as y dash, I'm not going to write dy dx, I'm not going to write fx and all the other stuff, just y dash. Now, the basic rule about these functions, the whole point about E is that the derivative stays the same. And we can go back to first principles and prove that, but not in this video, this is just the mechanics. So that would stay the same. And I always keep talking about the peekaboo, so if I cut it over the 5, that would be an e to the x, and it's got a 5 there. I do talk about the 5 is there for the ride. I do the same for sine, cos, tan, and a lot of other things. It's just there for the ride, it just stays there. It had no effect on the actual equation itself or on the derivative. Go to this one here. I can't really do peekaboo, but it has to stay the same. The basic rule is the exponential part stays the same. But it's got this extra part inside here, which is a 4. Now, simple rules, if you want it just as a statement of fact, you can just go times by 4 and write it at the front. I do tend to do this thing which I talk about is brackets. Everything has brackets, whether it's a square root line or whether it's an index or a power or exponent, whatever people want to call it. And I call all of this part in here the inside. Now when I talk about it, then we multiply by the derivative of the inside. You go, why does that work? And you can go, okay, through the process again of what it is. So we're going to multiply by 4, and that 4 happens to be the derivative of the inside. So maybe you've seen teachers say it and it just doesn't sink in. So all we've got is, if I ignore that for a moment, it's going to be the derivative of that is 4. So it's 4e, and the 4x plus the 1 stays the same. So the e section stays the same. Next one, talk all the time about those who haven't seen my videos before. I always talk about rearrange first. And years ago when I was explaining differentiation, I wasn't saying to people, we're going to rearrange first. And lots of people would think they would finish the question when they weren't. So first of all, using index laws, we need to rearrange that. When I move anything with a power or an index, if I move it from the denominator to the numerator, this part up here, the index, goes from a positive to a negative, or if it was a negative, it'd go from a negative to positive. So we talked about it changes sign. So if I ignored the 4 for a moment, that becomes e to the minus 3x. So on the denominator it's e to the power of 3x, but on the numerator it's e to the power of minus 3x. Now the 4's still there, nothing happens to the 4, so the 4 just stays there. All we've done is rearrange the question. So now it's in the form where we know how to differentiate. So the derivative is the e section, if I cover over the 4 again, the e to the minus 3x has to stay the same. It's got the 4 there, talking about a moment ago for the ride, still there for the ride. Now it's more complicated inside. Maybe I do this again with a red bracket and say it's more complicated on the inside. How much more complicated? And it's that much more complicated. So I keep putting an arrow on it saying that goes out to there. And I'm putting these arrows on, especially when we reverse the process and we're integrating or anti-differentiating. So the answer to the question is minus 3 by 4 is minus 12 e to the minus 3x. And I have students say to me, is that full marks and is that far enough? And most of the time I say no, it probably would be full marks in the final exams in most places. I don't know about everywhere, but it would be in a lot of places. So if I had a negative again as an index, and this is on the numerator, when I write that on the denominator, the minus 3x becomes a plus 3x. If you want to go back and watch some of my index laws, there's plenty on that. And then we've got the 12 here. Now, big thing about this minus, this negative that's written in the front, it doesn't really matter if you write it on the top or the bottom or out the front. I suppose traditionally most people, if I rub that off, will tend to write it out here in the front somewhere. I tend to write it just in the front and a bit above, I don't know why. One of those habits you get in life. The video's maybe getting too long. I'm trying to not get too long. So this one, it stays the same. I'm going to write 10 the 4x squared plus 3, so that all stays the same. There's no extra x here, we're not going to a product rule, it just stays the same. Then the part in the brackets, you've got to differentiate the inside and put it out here as a multiply. So the derivative of 4x squared goes back to normal 2 fours are 8x to the 1. And you can imagine what would happen if we had a cube there, and you'd end up with a square. Now the 3 just disappears and becomes nothing. So let's have a look at what we end up with. We've got 10 8 to 80 with an x. It's got an e and it stayed the same. So if you look back to the original question, we're just going to go 8x. You get to a habit where you just go 8x times 10. So 8x times 10 is 80x. But if you have to think that through, that's what's happening. Now we're back to here where I talk about rearrange. Either 2x plus 3, and we're using index laws and put that there. Now we've rearranged, we're also talking here about the chain rule. So I'm trying to fit all the possibilities in, but the video gets too long. Now we've rearranged, now we differentiate. The half goes to the front, just like always. E to the 2x plus 3 stays the same, and the half becomes a minus a half. So what are we doing? We are differentiating, and we're going to decrease the powers. So this power of a half, the e power doesn't decrease, but this is a power on the bracket. It's not an e power, it's just a half power. So that's going to go down by 1, and some people do have trouble with it, most people don't, when they just go a half, subtract 1 is minus a half. So look at the complexity of this. We go half times the number at the front, half times a 1 is a half. The inside stays the same. I can put arrows there as well to say it all stays the same. The whole inside section stays the same because of the chain rule. Then we multiply by, and I put this other arrow in all the time, we multiply by the derivative of the inside. So the derivative of e to the 2x is 2e to the 2x. And then you've got algebra to simplify. Sometimes in Western Australia the question will actually say do not simplify, which is nice because you just leave it like that and you get 4 marks. The obvious simplification is the 2 and the half will cancel. Most people will put the e to the 2x first, then they'll put the bracket last, and the bracket's got a minus a half there. But really, there's another step to it. We can move, when there's a power of minus half on the numerator, we can move it to the bottom and it becomes a denominator. But not only does it become a denominator, it becomes a square root on the denominator. So we've got e to the 2x. Sometimes I write on things, I say this is the numerator. It stays on the numerator, whereas this part here becomes a denominator. So that section is going to go to the denominator, and we end up with a square root of e to the 2x plus 3. And we've gone a long way there on that question.